Deep in the forests, far from paved roads and repair shops, machines had to survive on their own. In the 1970s, logging equipment wasn't built for comfort or fuel savings. It was built to crush trees, drag massive logs, and keep working no matter what broke around it. Thick steel frames, oversized engines, no electronics to fail. Decades later, many modern machines have come and gone. But these old logging beasts are still out there, climbing slopes, pulling impossible loads, and refusing to die. Today we're counting down the 10 old logging machines from the 70s built like absolute tanks. The iron monsters that proved toughness mattered more than technology. Get ready, because the forest never forgets real strength. Number 1. Caterpillar 518 Skidder. The Caterpillar 518 skidder is often described by veteran loggers as a machine that simply refuses to quit, no matter how badly it is treated. Introduced in the early 1970s, the 518 was engineered at a time when Caterpillar's philosophy revolved around longevity, not operator comfort or fuel efficiency. Logging environments are among the most punishing in heavy industry, with machines constantly smashing into stumps, dragging logs over jagged rock, and working in deep mud or snow for hours without rest. The 518 was built specifically for this reality, and its design reflects that mindset in every component. At the heart of the Cat 518 is a naturally aspirated Caterpillar diesel engine tuned for low RPM torque rather than high horsepower. This meant less internal stress, cooler operating temperatures, and a far lower chance of catastrophic engine failure. The drivetrain was massively overbuilt with heavy axles, thick drive shafts, and a transmission designed to absorb shock loads when logs suddenly snagged on terrain. Caterpillar engineers knew operators would overload the machine, so they built it with wide safety margins that modern machines simply do not have. The frame of the 518 is where its tank-like reputation truly comes from. Thick plate steel protects vital components, and the articulation joint, often the weakest point in modern skidders, was reinforced to survive decades of twisting under load. Hydraulics were deliberately slow and conservative, reducing heat buildup and seal wear. Even when hoses failed, replacements were easy to fabricate in the field. Many 518 skidders from the 1970s are still working today with rebuilt engines and refreshed hydraulics, proving that when a machine is built with brute strength and mechanical honesty, time becomes irrelevant. Number 2. Timberjack 230 Skidder. The Timberjack 230 skidder is remembered not just for its strength, but for how intelligently that strength was applied. Produced throughout the 1970s, the 230 was designed to be a true workhorse for professional logging operations that demanded reliability day after day. Timberjack engineers understood that raw power alone was not enough. A successful skidder had to maintain traction, balance, and durability in constantly changing forest conditions. The engine powering the Timberjack 230 was intentionally understressed, delivering steady torque without excessive RPM. This allowed the machine to operate for long hours without overheating or premature wear. The winch system, a critical component in cable skidders, was massively overbuilt. Loggers routinely pushed it far beyond its rated capacity, yet failures were rare. Gears were thick, housings heavy, and braking systems designed to hold massive loads without slipping. Structurally, the Timberjack 230 was built with a heavy yet well-balanced frame. Weight distribution was carefully considered so that the machine could pull large log bundles without lifting its front end or losing steering control. Axles and differentials were reinforced, allowing the skidder to handle sudden shock loads when logs caught on stumps or rocks. Hydraulics was simple, slow, and durable, with minimal reliance on precision components that could fail in dirty environments. What truly sets the Timberjack 230 apart is longevity. Many units built in the 1970s are still operational today, often with multiple engine rebuilds but original frames. Operators trust these machines because they behave predictably and can be repaired with basic tools. The 230 proves that true toughness comes from thoughtful engineering, not excessive complexity. Number 3. Clark Ranger Cable Skidder. The Clark Ranger cable skidders of the 1970s represent a time when logging machines were built with almost no compromise toward durability. These machines were unapologetically mechanical, with massive frames, simple drivetrains, and cable winch systems designed to withstand brutal abuse. Clark Rangers were not designed to be comfortable or efficient. They were designed to survive. One of the defining features of the Clock Ranger was its cable winch system. Unlike modern grapple skidders, cable skidders place immense strain on the winch and drivetrain during every pull. Clock engineers responded by oversizing every component. Winch drums were thick, gear teeth massive, and braking systems capable of holding extreme loads without failure. Operators could pull logs others wouldn't attempt, confident the machine could handle it. The drivetrain of the Clock Ranger was equally robust. Mechanical transmissions and heavy axles absorbed shock loads that would damage modern hydrostatic systems. Engines were tuned conservatively, producing reliable torque rather than peak horsepower. These machines were slow but unstoppable. When something did break, repairs were straightforward because everything was visible and accessible. Many Clock Rangers are still in service today, often running in small or private logging operations. Their continued operation proves a simple truth. When a machine is built with thick steel, mechanical simplicity, and massive safety margins, it can outlast generations of newer, more complex equipment. Number 4. John Deere 440 Skidder. The John Deere 440 Skidder from the 1970s is proof that toughness does not require size. Designed for smaller logging operations and tighter forest environments, the 440 was built with the same over-engineering philosophy as larger machines. Deere engineers knew that operators would push the machine beyond its limits, so they designed it to survive that abuse. Despite its compact size, the 440 featured a reinforced frame and articulation joint that could handle heavy twisting forces. The drivetrain was built to absorb shock loads, and the engine was tuned conservatively to prioritize longevity over performance. Hydraulics were simple and forgiving, allowing the machine to continue operating even when seals or hoses aged. One of the greatest strengths of the John Deere 440 was maintainability. Components were easy to access, repairs straightforward, and parts widely available. Many 440 skidders ran for decades with minimal downtime, often passing from one owner to another. Even today, it is not uncommon to see a 440 from the 1970s still pulling logs. The 440 proves that when a machine is designed with durability and serviceability in mind, it can become nearly immortal. It may not be fast or comfortable, but it was built to work and to keep working long after others failed. Number 5. Caterpillar D7 Dozer, 1970s. Before purpose-built skidders dominated logging, bulldozers like the Caterpillar D7 were the backbone of forest operations, and the 1970s-era D7 in logging configuration was nothing short of unstoppable. This machine was never designed specifically for logging, yet it became one of the most feared and respected tools in the woods because of its raw strength and survivability. Built with a massive steel frame, thick undercarriage components, and a naturally aspirated Caterpillar diesel engine, the D7 could operate under continuous heavy load without complaint. The secret to the D7's durability was conservative engineering. Its engine was tuned for torque, not speed, allowing it to push, pull, and drag enormous loads for hours without overheating. The mechanical transmission and final drives were enormous, designed to handle shock loads when pushing against rocks, stumps, or tangled logs. Logging versions of the D7 were often fitted with heavy winches, reinforced blades, and full forestry guarding to protect vital components from falling timber. What truly makes the 1970s D7 legendary is how little it cared about abuse. Operators pushed these machines through dense forest, over rocky ground, and up steep grades where modern machines would struggle. Breakdowns were rare, and when they occurred, they were mechanical and fixable. Even today, many D7s from the 1970s are still working in logging, construction, and land clearing operations. Their survival proves that when a machine is built for worst-case conditions, it doesn't age, it just keeps working. Number 6. Franklin 170 Grapple Skidder. The Franklin 170 Grapple Skidder from the 1970s was built with one philosophy: if something can break, make it thicker. Franklin skidders were famous for their brutal, overbuilt construction, and the 170 became one of the toughest machines ever to drag logs out of forests. Unlike lighter, faster skidders, the Franklin 170 relied on sheer mass and strength to get the job done. The articulated frame was built from thick steel plate, designed to twist under load without cracking. The grapple system was equally massive, with oversized hydraulic cylinders and heavy arms capable of grabbing and holding huge log bundles without flexing. Franklin engineers deliberately kept hydraulic pressures conservative, reducing stress on seals and hoses and extending component life. Drivetrain components were equally tank-like. Axles, differentials, and drive shafts were designed to absorb sudden shock loads when logs caught on terrain. Engines were detuned and under-stressed, allowing them to run for thousands of hours between rebuilds. Operators often overloaded these machines far beyond their rated capacity, yet failures remained rare. Many Franklin 170s are still operating today, often in remote or rough terrain, where modern machines suffer electronic failures. Their continued service proves that steel thickness, mechanical simplicity, and conservative engineering create longevity that no amount of modern technology can replace. Number 7. Tree Farmer C5 Skidder. The Tree Farmer C5 skidder is remembered by loggers as one of the heaviest and most intimidating machines ever to enter the forest. Built in the 1970s, the C5 was unapologetically massive, with a boxy design that prioritized strength over aesthetics. Its sheer weight gave it incredible traction and stability, allowing it to pull log loads that would overwhelm lighter machines. At the heart of the C5 was a large diesel engine tuned for low-speed pulling power. This allowed the skidder to drag massive logs uphill without excessive strain. The frame was extremely thick, designed to absorb constant twisting and shock without fatigue cracking. Axles, winches, and driveline components were similarly oversized, reflecting a design philosophy that assumed operators would push the machine beyond its limits. The C5's cable winch system was nearly indestructible, with heavy drums, thick cables, and powerful brakes. Hydraulics were simple and slow, reducing heat buildup and extending seal life. Operators valued the C5 because it was predictable, no sudden failures, no electronic surprises, just raw mechanical force. Many Tree Farmer skidders from the 1970s are still working today, often with rebuilt engines but original frames. Their longevity proves that weight, strength, and simplicity are still unbeatable in logging operations. Number 8. Pettibone Log Loader, 1970s models. Pettibone log loaders from the 1970s were less like forestry machines and more like industrial cranes adapted for logging. Built with enormous booms, heavy swing mechanisms, and extremely robust hydraulic systems, these loaders were designed to lift and stack massive timber day after day without structural fatigue. The key to the Pettibone's toughness was its industrial heritage. Frames were fabricated from thick steel sections, swing bearings were oversized, and hydraulic cylinders were enormous. Hydraulic systems operated at conservative pressures, prioritizing durability over speed. This made movement slower than modern loaders, but dramatically reduced wear and failure rates. Operators trusted Pettibone loaders because they rarely flexed or cracked under heavy loads. Even when lifting logs at the edge of their reach, the structure remained stable. Maintenance was straightforward, with accessible components and minimal reliance on specialized parts. Many Pettibone loaders remain in use today at sawmills and private logging sites, decades after their manufacturer. Their continued operation highlights a simple truth. Machines built with industrial-grade components and conservative design principles can outlast entire generations of newer equipment. Number 9. Koehring 6644 Log Loader. The Koehring 6644 log loader was never meant to be a lightweight, high-speed forestry machine. It was born from industrial crane engineering, and that heritage is exactly why it became one of the toughest logging machines of the 1970s. Koehring built machines for construction, mining, and heavy lifting, and when those design principles were applied to logging, the result was a loader that felt more like a stationary steel structure than a mobile machine. Everything about the 6644 was oversized, slow-moving, and brutally strong. The upper structure of the Koehring 6644 was built on a massive steel turntable, with an industrial-grade swing bearing, designed to handle constant heavy loads without deformation. Unlike modern loaders that rely on lightweight booms and high-pressure hydraulics, the Koehring used thick boom sections and enormous pins that resisted bending and wear. Hydraulic cylinders were huge in diameter, operating at relatively low pressures, which greatly reduced seal failure and heat buildup. This made the machine slower, but nearly impossible to overstress. The undercarriage and frame were equally tank-like. Tracks, rollers, and frames were designed to survive harsh job sites where maintenance was minimal. Operators routinely lifted logs well beyond what would be considered safe today, yet structural failures were rare. Even when wear eventually appeared, the machine could be rebuilt, pins replaced, booms rebushed, swing gears remachined. Many Koehring loaders from the 1970s are still operating today in sawmills and private logging yards. Their survival proves that when a machine is designed with industrial strength first and forestry second, longevity becomes inevitable. The 6644 didn't rely on technology, it relied on steel thickness and physics. Number 10. International Harvester TD25 Logging Dozer. The International Harvester TD25 is widely regarded as one of the heaviest and most intimidating crawler tractors ever used in logging, and the 1970s logging-configured TD25 represents the absolute peak of brute force design. This was not a machine built for finesse. It was built to push, pull, drag, and crush anything in its path day after day without mercy. In the forest, the TD25 was less a machine and more a moving wall of steel. At the heart of the TD25 was a massive diesel engine producing enormous low-end torque. Horsepower numbers mattered less than the ability to deliver constant pulling force under load. The engine was understressed, with thick internal components and generous tolerances that allowed it to run for tens of thousands of hours with rebuilds. Fuel efficiency was irrelevant. Survival was everything. The undercarriage was where the TD25 truly earned its tank-like reputation. Track frames, rollers, idlers, and final drives were enormous, designed to withstand shock loads from pushing stumps, rocks, and log piles. Logging versions were fitted with heavy winches, reinforced blades, and full forestry guarding. Operators used these machines to skid massive logs, build roads, and clear land that modern equipment would struggle to survive. Even today, TD25s from the 1970s are still working in remote areas around the world. Their frames almost never fail. Engines can be rebuilt indefinitely. The TD25 proves a final, undeniable truth about 1970s logging machines. When engineers design equipment for the worst possible abuse, those machines don't age, they become legends. Those were the logging tanks of the 70s, machines built for survival in the harshest conditions on Earth. While newer equipment relies on computers and sensors, these legends relied on steel, torque, and brute force. Which one of these forest monsters impressed you the most? Tell me in the comments. I read every one. If you love old-school machinery and unstoppable equipment, hit like, subscribe, and share this video with a fellow heavy machine fan. Thanks for watching, and until next time, keep the chains tight and the legends alive.